for that introduction. Okay, so today I'll be talking about composable architecture. Have people already worked with composable architecture? Or most likely you've probably just seen on Twitter, right? You've seen what like the point free teams are doing, pretty cool stuff. Hopefully I'll be able to give you a nice overview of it today. We'll be going into a good amount of code. I try to keep it as little code as possible on each slide. There's a good amount of slides. So I think actually what's the best thing to do is just if at any point you're like, Nikita, hang on, can you explain this a bit more? Or wait, I'm lost. Just raise your hands and just ask a question. I think that might work a little better than just keeping all questions at the very end. So yeah, if at any moment you're like, wait, can I ask a question? Go for it. I think it'll be even better. And yeah, I'm a high school student. Okay, so yeah, I'm Nikita. I go to the Lycée Français Charles de Gaulle. Shout out, it's a big French school in South Kensington. I play a lot of volleyball. I've been coding for the past 3 years, mostly in Swift, and I started off in SwiftUI native. I started with SwiftUI, sorry, and I know that a lot of you probably aren't using SwiftUI in your large teams. So also there will be a little bit of SwiftUI code. So again, if at any moment you're like, I don't fully understand SwiftUI code, again, just like raise your hands, I'll be really happy to explain. I've been working on a SwiftUI app for over a year, and it's all open source, because yeah, all open source. Alright. So what are the next 30 minutes going to look like? You're going to learn what the composable architecture is all about, why it exists, how it works, how one would go about making an app using the composable architecture. I'm mostly going to focus on the composition aspect of the composable architecture, because as it turns out, it actually has a really great story for testing too. Testing and TCA as a whole, composable architecture for sure, is pretty incredible. I probably will have time to show you. It also has a great story for modularity in the code base. Luckily, we have a talk about modularity right after mine, so that's bad, because I probably won't have time. I will also show you how integrating dependencies works. I'll be playing the server, and it should be pretty cool. Alright, so can anyone tell me what they think is the single most important thing to a high school student? It's like, what, yes?
Girl?
Sorry?
Get a girlfriend?
Yes. Close. No. Depends on the day. No. Anyone else?
Reflection.
It is scary, but hopefully by the time I'm in university, economics life will be okay and I won't be laid off at any company that I work at. No, honestly, I'd say it's time. Us high school students will always fighting for time. We never have enough time, especially in our friend's school. I have like school from 8:30 to 5 or 6 p.m. usually. I have extracurriculars. I try to have a life, including trying to get a girlfriend with varying success. But yeah, so time is my biggest constraint. So after learning SwiftUI and feeling like, okay, I do want to build an app, I needed to find an architecture that responds to my needs. So what did I need? Well, I needed fast iteration, right? I needed to feel like I had that kind of momentum where I could keep on going and not just kind of lose interest and be more interested in other things. Short recontextualization is really important because especially during the weekday, I'd only be able to work on it for about maybe an hour and a half. I couldn't spend that much time recontextualizing myself in the code base, thinking about what does this code do, what is it connected to. So short recontextualization time is really important. Being able to work on a single feature in isolation for multiple weeks, kind of related to short recontextualization. Also, if it compiles, it's most likely right. This is actually more of an homage to the Swift language itself, right? We love types, and it means I'm not going to get any weird value errors like I would in Python all the time. Easy testing is really important. Again, I probably won't be able to show you how the story for testing in composable architecture, but it's incredible and allows you to write tests really quickly and make sure that you're not going to get done dirty under the hood. And yeah, of course, I need more time. So before I describe you composable architecture, let's see how it describes itself. Point 3, the team behind it. Let's say it's a library for building applications in a consistent, understandable way with composition, testing, and ergonomics in mind. In this talk, you'll see a lot of the consistence. Hopefully it'll be understandable, but again, raise your hand if there's anything, ask a question, because I'd really be happy if everyone's able to rock it. Composition is a massive thing, I'll be talking a lot about that. Testing, unfortunately, no. Ergonomics are great. It uses a lot of the most recent Swift patterns. You've probably seen SwiftUI and stuff, so you'll also be able to see kind of what the Swift team has been working on. Yeah, and before we begin, I can't do a talk about the composable architecture without mentioning Team 1.3. You've probably seen them on your iOS Twitter. Stephen Sellis and Brandon Williams, shout out to them, they are doing really incredible work. They have a whole host of other libraries on their GitHub that has really cool stuff. A lot of them are actually used in the composable architecture itself. And the amount they've done for the Swift community is quite incredible. They have a video series where they post videos every Monday. I really recommend it. For me, it's just allowed me to take my what started as very low Swift levels to the next level. They teach on composable architecture, SwiftUI, but also more general advanced Swift design patterns, especially the functional programming ones, which are always great. Okay, so let's have an overview of the architecture. As you see, it's a unidirectional architecture. If there's any previous or current web developers out there, this diagram might look quite familiar to you. And that's actually because SwiftUI itself was very inspired by things like React and the Elm architecture, and so was the composable architecture. It's very similar to the Elm architecture in React in certain ways. So as is usual in the kind of more event-driven libraries, it all starts with a view and the user input. There's three big categories. There's the view, the reducer, and the store. The reducer and the store might sound a bit weird, but I'll explain it all soon. And then essentially the action, effect, and state types, they're just simple Swift types, are kind of the way that they message to each other, they communicate with each other. So it starts with the user input. From the view, for example, like a button gets pressed, the view sends an action to the reducer. The action is always an enum. It's always just a simple enum with a lot of cases, and you can have like sub-enums inside the enum so that all of the possible actions in your app can be represented by one single enum. Or we'll find ways, or you'll see ways that we can break down this enum into more composable ways. Then there's the reducer, with this plot that's kind of hiding this. So in the reducer, the choice of the reducer, well, essentially is just kind of a function. It takes the current app state, like just all the app state, it modifies it in base mutation, and then it sends effects to the store. So effects are essentially just any possible side effects in the store. And I consider side effects in composable architecture too, as just talking to the outside world. And the outside world is just talking outside your app, which means just anything that's not pure business logic of like modifying current app state. So that's like talking to HTTP endpoints, or talking even to the app APIs, right? All the sensors, core motion, core photos, I can't remember that's called. Yeah. So the reducer is going to be sending those effects to the store. The store, you can see it as kind of the runtime of the composable architecture. The store holds all the app state. And then it runs the reducer every single time the view sends an action. And the store runs those effects, right? So it runs all the messages to the outside world. And then the store communicates with you by just modifying the state. Because as you know, SwiftUI is a reactive framework. So whenever the state updates, SwiftUI will update its views accordingly. So that's kind of the graph. I might come back to this graph like during the talk because it's really helpful. And let me know if you also want me to go back to it at some point. Okay, so it's Thanksgiving today. I was supposed to have Thanksgiving dinner right now, so sorry, Mom. But in the Thanksgiving spirit, I made a turkey shopping delivery app. So you just like see a list of very nice turkeys, and you can draw down into it, and you see a detailed view of each turkey. So we'll call that one over there the detail feature, and this one here the shopping feature. You might also be curious about what this is. This is essentially how we're going to be talking to the outside world. I'll get into it a bit later. So it all starts with defining your domain. And what you do is you just define your state, right? We're starting with a detail feature. So all our state is just a simple value type. And what's great about composable architecture is that all you use are just simple value types. I can promise you'll never once have to write the word class in the composable architecture, which I find beautiful. You might have to write actor if you do like some kind of messy, like outside dependency stuff. But for now, it's really, really nice. Just simple value types. They need to be equatable so that composable architecture can diff the state really efficiently, so it doesn't update all of the views when some views don't care about the state that you're modifying. And it needs to be identifiable. Now, identifiable is just a simple prototype, most of you probably know it, where you just have like an ID property, it has to be hashable. Essentially, most of the time, it's just a UID. And that ID, I just dumped it inside of the type itself. It has to be identifiable because SwiftUI loves IDs. It loves identifiable values. And it's how SwiftUI is able to also diff between its views and know which views needs to update. The composable architecture, as we'll see, is very similar. And we'll see in general, there's a lot of kind of parallels between composable architecture and SwiftUI, so maybe hopefully in this talk you can actually also learn things about SwiftUI in parallel. So yeah, super simple value type. I just like define it as hierarchy, description, it's actually description. Again, these two are related to that button over there, which I'm not talking to you about right now. I'll hold that off for later. Yeah, so super simple. After the state, you always define your action, right? That's what I said. You just have your action enum. It needs to be equatable, not for the same reason, but it needs to be equatable, mostly because of testing. Unfortunately, you probably won't be able to see why, but on your own, the documentation is amazing on composable architecture, so you'll definitely be able to see that. Yeah, so you have your action type that essentially just describe all the actions that the components view. Get description will just be sent if I were to press on refresh description, and cancel often tabs. You can just imagine I'm refreshing the description, and then cancel button shows up because I want to cancel the request. And this description response thing is quite special. Remember what I said about actually, I'm not sure if I mentioned this, how when you run an effect, right, the effect itself, when you just talk to the outside world, you'll see it's actually mostly using Swift async await, which is really nice. You have to return an action in that effect, right? Because you're getting information from the outside world, so obviously you have to do something with that information. And you're going to do that in the reducer, right, through the action type. So in each effect, you have to, in the end, return an action type. And here, the action that's returned from the task, from the effect they sort of know about yet, is description response. And you see the associated value is task result. You can essentially think of task result as just result, the result type of Swift. It's more because of like the specifics of how async await handles errors, in the sense that async await only just throws pure like erased error types, which are not equatable, and we need your action, to be equatable for testing purposes. So we just use task result type, which doesn't carry the error type and only has the value that's returned. And then, so now we have a state and an action, and we put it all together in a feature reducer. And the composable architecture just calls it a reducer, but I call it a feature reducer because really you should have one reducer per feature. So we conform it to the reducer protocol, and then our state and our action types live inside of that. And then it only has one requirement, much like SwiftUI, right? That only has one var body sum view requirement. A reduce function takes an in-out state, which just, it just means that we can modify the state as much as we want. It takes the action that was sent by the SwiftUI view and returns that effect, right? If you come back to my diagram, it's the exact same thing. So all we do is we just switch on the action that was sent by the SwiftUI view, and we just modify the state accordingly, right? So if the cancel button's tapped, then yeah, I'm going to put its actual description to false, and then I'm not going to return an effect because I just decided that I don't want to return an effect when this action is sent. However, here, as you see, I am returning an effect, and I'm really sorry about this. Again, I'm hiding what the effect actually is and keeping that for later. But as you see, I'm returning a dot task. All a dot task really is just run some async await code inside of this task and return an action type of once. That's kind of one of the effect types of the composable architecture, allows you to return from in a reduced function. So now, how does it look like in a view? Well, I mean, depending on the familiarity with SwiftUI, this might look quite simple or completely alien, but essentially all we have is we just need to get a reference to the store, which is, remember, I said it's the runtime of the composable architecture, right? It's the one that's updating the view, so it makes sense that we need to have a reference to it. It's a store of that detail feature. That's just a reducer that I had right before. And so then in my body, what I need to do is you see this kind of this weird like view called with view store. Kind of weird. I honestly didn't like it at the start. But all it is it turns the store into a view store. And a view store in the composable architecture, all it really is just an opportunity to chisel away at the state that lives inside of the store, right? Because maybe we don't want to observe or we don't want to react to all the state inside of the store that's given to us. So with view store gives us the opportunity. As you see here, I'm not using the opportunity because I mean my state is quite simple. So really I actually need all the state that I defined. So I just put $0. Usually you maybe have a key path where we can just reference the state you actually care about to react in the view. So I'm giving it a view store, and then it uses dynamic member lookup, so it's really nice for accessing the state. So I just reference the state. Here you see in the button, whenever the button's pressed, I send the get description action case to the view store. So that's how you send events from a SwiftUI view to the store. Cool. Honestly, I think it's quite simple. I mean, I don't really think, I'd say it's probably reasonable, but I'm slightly biased. Okay, so we defined the detail feature, right? This works amazingly. Well, I want to get to this. So I want to get to a list of turkeys. But the thing is, I don't really want to have to do all that index jumping and stuff, you know, that you usually might have to do with when you have a detail feature, you hoist it up to a list of detail features. But the composable architecture gives you really, really nice tools for that. So once again, I'm just going to define the state for this shopping feature, and all it is just an array of the detail feature state, right? But it's not any array. It's what's called an identified array. Remember earlier how each turkey had a unique ID? And this is why. Because as I said before, SwiftUI loves unique IDs, and so does the composable architecture. So the composable architecture is going to need it needs an identified array, because so that it can recognize which turkey sent which action from the detail feature. This will become more clear later as I go through when I show you the reducer. But just know that we need to use an identifier array for good purposes. Then we just define our action also. And notice here that my action, I mean this remove turkey one, is just one where I can delete like a turkey from the list. But this detail case is really special. All it is essentially me wanting to hoist up a detail action into my shopping list action. And so I just have some associated values. I have my detail action, and then I have the ID, right? The ID when I sense it. This is why I use an identified array. It's because I want to be able to access which turkey did what action purely through the ID, which an identified array allows you to do. And then I have my shopping feature. So again, exactly the same thing, reduce the protocol. And notice that I'm being very deliberate about my slide titles. I want to show that this is really the same fundamental building block as before. And this is what I meant by short recontextualization, right? Because it's all the same, it's essentially all the same code, just implementation is different inside of the body and maybe inside of the implementation side effects. And this is what I really like. I'm just composing these building blocks together. So you might notice that we don't have the func reduce anymore. We have something else, and this looks actually a lot more like SwiftUI. SwiftUI, you have your var body some view. Here you have var body some reducer protocol. I'm able to tell the reducer protocol its associated types of state and action. This is using a new Swift feature that allows you to give it associated types just in the name. And And this body plays really a lot of the same function as the body in the SwiftUI view, where it gives me a resolvable context. That means that I'm able to compose these kind of blocks together without having to use like arrays or commas or whatever, just able purely using their resolvable syntax. And so we have this new type here called reduce. All reduce is essentially the same thing as my func reduce before, but just like as a type, because I want to add things to that reduce, notably this for each, which I'll explain right now. But so in my reduce state action, switch action, exactly the same thing as my func reduce. But then I have this for each thing. And this for each is really, really important. Essentially, it's what allows me to hoist up the detail feature into the shopping feature. Because what I'm telling it is, okay, whenever you receive a detailed action on one of the turkeys from the turkey road, that's identified by SwiftUI ID, I want you to run the detail feature. That's all I have to do. Zero indices, nothing. That's all I need to do to be able to hoist up a child feature into the parent feature using that as type. Also, this is not a typo. This is actually because action, if you see, is an enum, except Swift doesn't support key paths for enums, right? I'm actually working on it right now. Still doesn't exist yet. So the ingenious team at point 3 created their own key paths for enums, because they're cool like that, called case paths, which literally just a forward slash. And at runtime, it will build a kind of embed and extract function that you're going to have at compile time with key paths. But it's really efficient, it works really well. And the view, I don't want to spend too much time on this, but the view, it's the same thing. I have a reference to the store that holds the shopping feature now instead of the detail feature. And what I'm doing is, I know that my detail view expects the store that only cares about a detail state, right? A detail action for each turkey. So what I'm going to do is I'm going to use this for each store, which is given by the composable architecture. You can think of it as whenever the composable architecture gives you a tool, like kind of a building block inside of its producer, right before it was the for each, it's going to give you a parallel building tool for the view, for the SwiftUI view. Here it gives me here I can use a for each store, which essentially will just derive a new store that only cares about the detail state and the detail action from my identified array and that enum that I had before, right? So this is all I need to do to now essentially have behavior for each of the detail features, where I just define the detail feature in isolation by itself. And now I just need to do this to now have it work as a list automatically, which is really, really nice. Okay, but what if I wanted to do have two distinct tabs, right? I don't know if you can see here. A shopping tab and a profile tab, because I mean it's Thanksgiving every year, so it's sure you want a profile to remember which Thanksgiving turkey you bought last year. This is going to show you the third building block for the composable architecture. It's actually kind of the simplest, so don't worry if you're kind of tired of me showing so much code. This is a really, really simple one. All it's going to let you do is just have a child feature and hoist it into a parent feature, so you can have sibling features together. So once again, because I have this tab thing, I can just maybe define an app feature, right? It's going to hold the state and the actions for the shopping feature and for the profile feature. And so that's what I do. I just create, again, a new simple value type state. I have a shopping feature, I have a profile feature. Same thing with the action. It's super simple. I just have a shopping case with an associated value that has the action. Same thing for the profile. Really simple, really nice. And then, just like before, I call the app, I create a new reducer. I call the app reducer here. It's just like a feature reducer like any other, which kind of just goes to show again, just like how nice it is to have the same building blocks in every single level of your app, right? And same thing as right before, I conform to the reducer protocol using the volume property this time, not using the func reduce like I had in the very first feature. But here I have a new building block called scope. And all scope does is just essentially derive a new reducer, but that only cares about a single sub-feature, right? So here, I have a key path to the shopping state, and then a case path, right, the not a typo one, to the shopping action, and same thing here. And so now, essentially, I've hoisted up two sibling features up into the parent feature in, 6 lines of code. I think that's pretty cool. And the app view, super simple. Again, promise to the store, that store that cares about the app feature. This is just a tab view in SwiftUI. It's really nice, definitely nicer than doing a tab view in Market. Where I just had a shopping view. And remember what I said about we have a tool, a building block in the composable architecture. We'll have a parallel one in a SwiftUI view. And here I just have a method on store.scope, where I'll just give a key path to the child feature that I want to care about, so that I can give it to the shopping view that only cares about the shopping state and the shopping action. Oh, cool, right. That was pretty intense. But we're not done yet. Actually, I think the coolest is yet to come. So remember that empty description thing on the detail feature. So initially, what I wanted is to kind of to be a description for each of the therapies, kind of marketing, whatever, make it kind of sellable. But honestly, I couldn't really be bothered. So instead, what I prefer doing is just having AI do it for me. So why not? Just hit the OpenAI GPT-3, which is their largest language model, pretty incredible. I think we do this. I think in this case, maybe it's fine because I'm just asking it to lavishly describe flavors to turkey that just came out of the oven for Thanksgiving. So I think in terms of ethics, I should be okay here. And actually gives me really good answers. It's going to give me a completely unique answer every single time. Here it tells me, turkey is golden brown with crispy skin. The juices are running clear and the meat is cooked through. The gravy is thick and rich, making the turkey drippings is the perfect finishing touch to this Thanksgiving feast. Quite poetic, if you ask me. And so what I want to do is just whenever I open the detail feature, it just generates a new description. And I press description and it generates a new description. And OpenAI has an API, so I'm going to do the most vanilla post request using URL session to the OpenAI service. It's going to be super nice, but it will show you how nice dependency management is. How nice dependency management is. Because this is a dependency, right? I mean, I'm talking to the outside world, so this is a side effect that we can model as dependency. And I want this dependency to be as easily replaceable as possible. And this is really important, especially for SwiftUI, previews. SwiftUI, you can have these instant previews where whenever you change your review code, it instantly updates. Except they're famously flaky. And they're flaky mostly because SwiftUI previews don't know how to run side effects. They don't know how to talk to the outside world, right? Especially for any side effect that hops off the main thread onto another thread. It really doesn't work well. This is really important to have that kind of really fast iteration that SwiftUI is supposed to give you, or at least how Apple marketed it. So I'm going to create a dependency. In composable architecture, we'll call it a client, right? So OpenAI client. And I just have a property that stores a closure, an async closure. Because composable architecture works really nicely with Swift async await. It's really cool. Settable just means that it's safe to run across threads. It's not actually super necessary here. And it just returns a simple string type. No completion handlers, no combined publishers, just a really simple string type. You might be going like, Nikita, have you ever heard of protocols? Have you never heard of protocol-oriented programming? And actually, I love protocol-oriented programming. I mean, the reason why the composable architecture is, in my opinion, so ergonomic is thanks to protocols. But to me, protocols are only better than this if you're like consistently and always abstracting over them, right? Especially using like generics. But as we'll see, we don't really need to do that. So we can actually just keep it simple, not have as much boilerplate, and just have this really simple type. Okay. So then what I do If you work with SwiftUI, you might recognize this. This is just like how you define an environment value in SwiftUI, which is also supposed to kind of be a value we can access from anywhere in SwiftUI. You just conform it to a dependency key, and you have a single required performance, which is live value, where you give it the value of your dependency in the live state, which is essentially like when you're actually running the app installer or on your user's phones. I am purposefully not showing you what the implementation is because I have a couple of things I want to show you first. And then what I do is I just register it, essentially I just register it in the Composable Architecture's dependency system. Again, if you've worked with SwiftUI, this is literally identical to what you have to do in SwiftUI. This is like, yeah, this is not useful code, just registering it in their system, but in a TypeScript way, which is really useful. Okay, so I have my live value, but what would be great is if I have a value I use in my previews, and then maybe also a value I use in my tests, right? And Composable Architecture does this really easily, because actually you can fulfill another optional requirement for preview value, where you just give it the value they want to use when the dependency is being run inside of a preview. So here I'm just literally telling the string, this is the preview. Because remember, I defined the function as just an async closure that returns a string, so that's all I have to do. And then I can also create a test value. Now we won't really be using this because I'm not going to show you how testing works in Composable Architecture. But what we do is the Composable Architecture has something called unimplemented, which is when you just tell it, I expect this dependency to never be hit. Like, I never want this dependency to be run in this specific test. And so it can essentially give you assurance that it will never be hit. Otherwise, it's going to turn into an XCT fail. So it's a really good way to know which dependencies have been used inside of the tests. Okay, so I have the live value. This is the implementation of the dependency. It's again like most vanilla like networking codes. I create a GPT-3 request. I just do a simple GRAL request to their API. Hair fuels, posts, HTTP. I encode the body with JSON, and then notice it's great. It's really nice, really simple. No completion handlers, no weird like unwrapping optional errors and stuff. No long chains of combined publishers, although combined stores have a piece of my heart, but it's really nice stuff. Just pure async way. I can just use try catch syntax, right? Really simple. And then I just return the description, and that's it. So that's all it takes to define a dependency in the Composable Architecture. And the way you use it is really, really cool. Because, so going back to our detail feature, right, where we have an individual turkey, what I do is I say, okay, well, here's my dependency, OpenAI. And it just gives me the OpenAI type, the OpenAI clients that I defined before. This is just a property wrapper, it's a key path, really mirroring the SwiftUI syntax that's used. It's really nice. And then all I need to do, now that I have this dependency defined, which is just now a property on the detail feature type, right? Then I can just call the generate description endpoint. And notice how 0 of the implementation details of generate description were leaked into this reducer. So I just try to base it. Remember, I had this like weird task result type instead of using just the normal result again because right now in async way, error types are all erased, although that might change not too long. And then remember, from a side effect, I have to return action. So that's what I do, right? Because now I have information from the outside world included in that response. So now I just return a new action with a response. And then I can have more code from my reducer that reacts to the response, right? Whether it was a success or a failure, because task result is just like a success failure, And actually, let me just show you how it works. It works. Yeah, okay. It's terrible. Where's my cursor? Yeah. Okay. I can just request description, test the endpoint. Here we go. A new description generated by OpenAI's most advanced language model. Perfect. Okay, I told you about SwiftUI previews, right? Well, it turns out that because I defined that preview value, SwiftUI previews will automatically use my preview value implementation. So I don't even have to do anything, and it just gives me this is the preview description, right? Without having to do the thing. And this is great. It means that you can like modify as much as you want, test out the different kind of responses, this is how your layout works, and really keep a fast iteration on your UI, because SwiftUI previews, when it works well, is incredible. But I mean, what if I wanted a different description for my previews, right? Or for this specific preview, or for just like right now, say I wanted a new description. Then all I have to do is just in the preview, I just have this method called dependency, where I say, okay, well actually for the OpenAI dependency, I just actually want a new implementation. And I'll just say happy Thanksgiving. And it works. That's all I have to do to just pull out and shove back in a whole new implementation of the dependency. And there you go, it works. So yeah, that's it. And I don't know, I hope from this you kind of, I'm not expecting you to have now become fluent in composable architecture and tonight like rip out like a whole new app, right? But I hope this will give you a really kind of all-round vision of why the composable architecture works so well, personally for me, right? A time-constrained high school student. It's the composability that really matters in the sense that I can work on a single feature in isolation. And then to hoist it back up into the rest of my app is so simple. The composable architecture gives me those tools, right? There's the for each, there's the scope. And because the composable architecture gives me those tools, I can work on it on isolation, which means I can recontextualize really short into. I won't be able to get into it, but it also means that, for example, we can have multiple modules inside of the Xcode project, inside of the Swift package, right? We have multiple modules that all compile independently, and each of them is just a feature, which means I can work on a feature in real isolation, because I change the code on the feature, and I don't have to recompile the rest of my app. So that's what composable architecture brought me. And I mean, you might have noticed, the constraints I described are probably constraints that you will have in your large professional developer teams. So yeah, if you're considering using composable architecture, that's why you should. Any questions? Yes?
What was your background before you started taking this one? Did you build iOS stuff before, and what architectures did you experience?
Yeah, I mean, the big things. Like composable architecture is probably one of my first major architectures that I used. When I started with SwiftUI, I mean, I was a completely new programming user, right? So I was just doing the classic spaghetti code, right? Of like bindings all the way down, really ugly code. Then I did some MVVM, right? Observable objects, switch to the big debate in SwiftUI community whether you should have more of these kind of unidirectional data flow architectures or more of an MVVM style. I found that MVVM still led me to do spaghetti code. Maybe that's more of a function of me being a bad programmer at that time than the MVVM being bad architecture. The composable architecture gave me that kind of discipline, right? It gave me discipline, which is kind of what I was looking for. And then it turned out it also gave me all these other advantages. And there's even more that people talk about. Testing is incredible and maybe one of the major features of the composable architecture. So yeah. Yes?
Would you recommend
I'd say, I mean, the only reason for SwiftUI, right? For UIKit, like, there's support for it, but it's not natural. And I think it's probably other more natural architectures you can use for UIKit. But if your team is considering SwiftUI, then yes, this is definitely the best architecture to use SwiftUI, because it just gives you those tools to have the momentum in manual SwiftUI. Because SwiftUI is like complicated. Apple marketed it as like the most simple way, you know. Oh, my 10-year-old son could create an app with SwiftUI. Completely wrong. I mean, if you want to do anything more than a counter app, a to-do app, or like a turkey shopping app, SwiftUI, the implementation complexity goes up quite exponentially. The composable architecture gives you the guardrails, right? It can give your team the guardrails to use SwiftUI in the way I find it was kind of envisioned to be used. I mean, Apple He purposely didn't say how you should be using it, but they did give me hints of like they're inspired by React, inspired by architecture. So this feels really natural. But yeah, only for SwiftUI. Yes.
Yeah, what I noticed is you use like a concept of a single state, right?
Yes.
But some part of the state may be something that you want to sync between client and server. Like let's say you have a list of transaction, like let's say it's completed or pending, whatever. And in some cases, like here, you have the field like is fetching transaction.
Yes.
You seem more not like a state of the model, but on-device state on this particular device, right? So do you find it useful to keep it also a part of a single state entity, or to distinguish it somehow, right? Because in other architectures like MVVM, you would have concepts like presentation layer, model, like persistent, whatever.
That's a really, really good question. The best answer I can give you is that I think composable architecture consider state as like anything that might affect the UI, the running UI of the application, right? And whether you're fetching something from the server or not, like something that the user asks for, whether fetching from the server or not, I mean, it should be represented in the UI, so it makes sense that there would be in the state value type because you want to react to it in your views, right? But I mean, if you're just like doing it kind of fire and forget request to the server, you can do that. There's an effect type which is called fire and forget, where you can just like run some async await code and not have to return any actions from it, right? So it won't be affecting your state, it won't be affecting your app by itself. We just pick a server and that's it.
Should we call it?
Is it quick?
Yeah. You mentioned this architecture or set of classes. It runs very well with SwiftUI, but if we want to do something similar in UI kit, should we have to go to a state machine with input which goes to different states or something similar? Because it looks like a couple of state machines or so.
Honestly, I'm not sure because I'm not good at UI kit. I mean, I started with SwiftUI. They do have SwiftUI support. They do have UI kit support, and I mean, like, and there are people who are using official UI kit. I'm just saying that some of the advantages it brings you are there, but I mean, the things like for previews, right, and for environment, that kind of thing, really don't exist in SwiftUI. So I would honestly probably not even consider using Composable with UI kit, and there's plenty of other much more mature, I'd say, architectures for that. I'll take 30 seconds. One last thing I want to show you is the composable architecture is being used today for concrete things. I mean, we have this incredible new browser. This browser called Arc. That's being made by a company called the browser company. It's really great. It's like a big startup. They're getting a lot of funding from Pinterest, from founders of Pinterest and stuff. They have these sidebars. It works really well, really smoothly. It's a big, big app. You have probably like a couple 100,000 lines of code. And the composable architecture works great. And I believe, I mean, their senior engineering lead is Krzysztof Zablowski, I'm not sure how to pronounce his name, the really ripped Polish dude. He's great, and so he works there now, and he's the one who introduced composable architecture to them. And yeah, just showing that like it's being used today to create the apps of tomorrow. Yeah.